Hey everyone, how are you guys? I hope you guys are doing extremely well. So today is day 15th of my 30 days of hashtag 30 days of talking to camera challenge, and I have completed a milestone. I have completed half of this journey thanks to your support and thanks to me also, that I can, I have consistently recorded my videos for 15 days straight. I haven't done this before, or I can't have ever imagined that I could do this. So thanks to all. And today is the first day when someone commented on my video, and I really loved that. I haven't seen that what was the comment, but I got a notification from on the YouTube that I have received a comment on my video. So yeah, that's really great for me because I don't know what to say. I'm really very happy. But one small wrong problem happened with me right now before recording this video. I right now recorded a 30 minutes video. I spoke to camera literally for 30 minutes, and after that I saw that the record button was not on. Sorry, the record button was on, but my camera was flipped to the opposite side because I'm recording with my mobile and I'm recording with back camera, because the quality of my back camera of my smartphone is better as compared to the front camera. Usually it happens in all the mobile phones, but then I saw that that my camera was facing at the at back, so it made a little bit of mistake. So I had to delete the whole video, and I am recording this video once again. So let's bear with me and let's start this video. I have discussed about some searching algorithms, sorting algorithms, some problem based on searching and sorting algorithms, and linked list. I have discussed types of linked list, what is linked list, and some basic operations on linked list. So today I will discuss about doubly linked list. I have already made a video on single linked list in yesterday. So today I will be talking about doubly linked list. So what exactly a doubly linked list is? Let's understand. In a doubly linked list, there are two pointers in each node. One is previous pointer and one is previous pointer and one is next pointer. So what it does is, the previous pointer points to the previous node of the linked list and the next pointer points to the next node of a linked list. So let us understand one thing. What was the problem with single linked list? The problem with single linked list was we can only traverse it from one side. We can't traverse it from back. But in doubly linked list, we can traverse it from both sides. We can go from front to back also and from back to front also. So this is a benefit with doubly linked list. Now, let me give you an example where doubly linked list is used. You have seen the images in your gallery. You can swipe unlimited number of times. You are watching reels on Instagram or TikTok. So what you do is you swipe one time to up and one time to down. Both the videos are connected. The address of the first video above this video is stored in this video, and the address of this video is stored in the video above. So this similar concept is used in doubly linked list. What if you can only go down and you can't go up? So that was single linked list. I am just telling this for you to visualize the real life applications of where doubly linked list is used. Now what happens here is, there is a next node. As I have already said in single linked list, the next node is storing the address of the next node. The next pointer is storing the address of the next node, and the previous pointer is storing the address of the previous node. In doubly linked list, each node is divided into three parts, that is previous, value, and next part. The value is the main part where the element is stored, where the value is stored, and the next part contains the address of the next node, and the previous part contains the address of the previous node. So this is what happens in doubly linked list. Now let's discuss some basic operations that we can perform on doubly linked list. So what are few basic operations that we can perform on doubly linked list? I have already discussed these operations in single linked list also, but I am discussing this in doubly linked list also in case anyone has not watched that video. So the basic operations that we can perform in doubly linked list are: insert an element in the linked list. We can insert any element in the doubly linked list at the head or at between in the linked list, somewhere in between, or at the end of the linked list, at the tail. Insert head, insert tail, or insert anywhere. So inserting anywhere is a general case, and it is very necessary to understand this in case of doubly linked list. Now the second operation is delete any element from the linked list. Now as I have told in insertion case, we can do the same in deletion case also. Delete head, delete tail, or delete from middle of the linked list, delete any element from the linked list. So this is basically the general case for the linked list. Now third operation which we can perform is print all the elements of the linked list. So we will traverse all the linked list and we would print all the elements of the linked list. So these are the basic. Now fourth one is reverse the linked list. Suppose we are given a linked list as 1 2 3 4 5. Now I have to reverse the English like 5 4 3 2 1. So how I can do that? We can't do that in the case of single English, because I will tell you, then I will discuss the topic, and I will tell you why we can't do it. So let's now first to see the problems that we can solve with doubly linked. There is one more thing is like search any element in a linked list. So now let's talk about some of this problem. So before telling that, let me give you a small intuition. Before solving any problem in linked list, if you are given any problem in linked list, so what the first few things that should come to your mind is, first is zero element case. What if there is no element in the linked list? What if there is no head in the linked list? There is nothing in the linked list. So this should like first come to your mind. Second is one element case. What if there is only one element? If there is zero element, then head should be modified. Head will be modified. And there is one element, then hand can be modified. Hand cannot be modified. And if there is first element in the linked list, like first one element case and then first element case, then also head can be modified or head cannot be modified, and then comes the general case like all the other cases. So the first few cases are the base conditions of our any operations that we can, if any problem or any operation or any question that comes to our interview or exam in the case of linked list. Now let's talk about insert in head. How we can insert an element at the head of a doubly linked list. So as I have already said that doubly linked list, the nodes of doubly linked list has two pointers. First one is previous pointer and one is next pointer. The previous pointer points to the shows the address of the previous node, and the next pointer stores the address of the next node, something like this. So you can imagine it like this. So now what we have to understand is, suppose if I have to add any element at the beginning of the linked list. Now what I can do is, beginning of the linked list means at the head of the linked list. So what I will do is, we already know that head stores the address of the first node. Now suppose I have to add a new node. So now what I will do is, the next of head, like the address which head is storing, will now head will now store the address of the new node, and the previous of new node will store the address of head, like something like that. And the next of this new node will store the address of the first node, and the previous of first node, which was previously storing the address of the head, would now store the address of the new node. In this way we have inserted an element at the head of the linked list. Now let's discuss about our another case, inserting any element at the end of the linked list. So inserting at end is also similar as inserting at the head. What we will do is, we will traverse through whole linked list and see, we will traverse through a temp variable in the whole linked list, like a temp node, and we will do that temp.next, temp.next, temp.next. We will run a while loop and we will see until we found a case where temp.next is not equals to null. Suppose we have to run until temp.next is not equal to null. So if temp.next is not equal to null, that will move forward, and if temp.next is equal to null, then we will stop. Then we know that we have reached to the end of the linked list. Now what I will do is, we will take the new node, and the next of the last node, which is previously pointing to null, we will point it to the new node. Suppose the next of new node is pointing to null, so this is null and this is state. So I'm just like, it's just my hypothesis, it's not in reality. I'm just doing this type of funny things to let you explain. I know this is not funny, and I'm trying to be funny and trying to be a good teacher and all that, those things I'm trying to be. I'm not actually that type of person, but I hope doing these videos and doing all this stuff will change my personality completely, and I would eventually become that type of person. You must have heard a quote that try. Sorry, I don't remember that quote quote actually. So there is a quote something that says something like, fake it until you make it. So currently I'm just faking it in front of you guys. So yeah, so sorry, let's come back to the topic. So previously the last node, the next of last node was pointing to null. Now what we will do is, the next of this last node will point to the address of new node, and the previous of new node will point to the address of next node, like this. So next node, the last of next node, which was previously pointing to null, will point to new node, and the previous of new node, which was like pointing to nothing, now will point to the last node, and the next of this new node will point to null. So in that way we have inserted the element in the end of linked list, that is insert at tail. I have discussed insert at head and I have discussed insert at tail. Now let's discuss one more special case, that is insert at any position in the linked list. So how we can insert at any position in the linked list? Suppose I have to insert at middle. Suppose there is a linked list in which one element is one element is A, other element is B, and the third element is D. Now I want to insert C between B and D. Suppose I am just giving an example. Now what I will do is, and these are not elements, these are actually nodes. I hope you are understanding what I am trying to say. Many times I misspell nodes with elements or nodes with values, so just like understand those things, and I will try not to misspell, but if I am just misspelling, so please cooperate with me and try to watch this whole video. Now if I have to insert any element, if I have to insert an element D between B and C, A, B, C, and I want to insert D between B and C. So what I will do, I will traverse through B. First I will traverse through B, and I will check the condition if the next of B is C, like I have to insert between B and C, and so I will traverse till B, and now the new node which I will to insert, the value of which node is D. What I will do is I will check if the next node, I will point the next node of this value to C, and the previous of C, which was previously pointing to B, to D. Like the next of D would be pointing to C, and the previous of C will be pointing to D, and the next of B would be pointing to D, and the previous of D would be pointing to B. So let's me explain it one more time. Previously the next of B was pointing to C, now the next of B will point to D. D is the new node which we want to insert. Previously the previous of C was pointing to B, now the previous of C would point to D. D is the new node which we want to insert, and the previous of this new node, previous of D, would point to B, and the next of D would point to C. I hope this is clear. I have explained it like many times. So in this way we can insert any element in the linked list in any position we want, whether it is first position, whether it is at any general case like anywhere in between, like second, third, or fourth, or fifth, or sixth, or any position, or and the third is like if you have to insert in the end position. Now let's move forward. I forgot to tell one thing, that insertion in linked list takes big of one time complexity, that is it takes constant time complexity. And insertion is linked list, what does it mean? Like what does it mean to insert in a linked list? Inserting in the linked list basically means creating a linked list. Suppose there is no linked list, so first we would insert one node, then only we can insert many nodes, and then eventually we have created a whole linked list. So inserting a node in the linked list simply means creating a linked list. Now there is like another operation, inserting in a sorted linked list. So what if we are given an element and we have to insert in a sorted linked list? Suppose the linked list is 1 2 3 4 5 6 7 8, and I have to insert 1 2 3 4 5 6 7 9, and now I have to insert 8. So how will I know that where I will insert 8? Now what I will do is I will traverse through the linked list until I found the value which is, I found the place where the previous value is less than 8 and the next value is greater than 8. So at that point I know that is between 7 and 9. So what I will do now is, I will 8 is my new node, and 7 is my previous node, and 9 is my next node. So I will do the same thing as I have discussed in the insertion at any place, and that was the general case. I will do the same here also, and I will insert that node in between of 7 and 9, and in this way I will insert the element in the sorted linked list. And I hope you can imagine like how we can create a sorted linked list. Suppose I have few elements like 5 6 8 12 14, 5 6 8 12 14. First someone give us 8, now I will insert 8 at the beginning. Now 7 gave us 5, I know 5 is smaller than 8, so I will insert 5 again at the beginning. Now someone gave me 12, now I know okay 12 bigger than 5, so I will insert after that, but 12 is less than 8, so I won't insert it there. 12 is bigger than 8, yes 12 is bigger than 8, so I will insert it after that. Now someone gave me 7, 7 greater than 5, yes 7 greater than 5, 7 less than 8, yes 7 less than 8, so I will insert is there. Someone gave me 13, 13 greater than 5, yes 13 greater than 7, yes 13 greater than 8, yes 13 greater than 12, yes, so I will insert 13 at the end. So in this way we can create a sorted linked list. I hope this explains well and this example was clear. Now let's move on. Now let me talk about deletion in a linked list. How we can delete any element from a linked list. Suppose we have to delete deletion of any node from a linked list. We have again three cases. These cases are similar as insertion in a linked list, that is delete from the beginning, delete from the end, or delete from anywhere in the linked list, that is the general case. Now how we can delete from the beginning of the linked list? So to delete from the beginning of the linked list, what I have to do is, suppose the head is pointing to the first element. Now what I will do is, the next of head will point to the second element, and in that way our first element would be deleted. The next of head will be pointing to the second element, second node, and the previous of second node will pointing to the head. Previously the next of head was pointing to the first element and the previous of first element was pointing to the head. Now next of head is pointing to the second node and the previous of second node was pointing to head, so nothing is pointing to first node, so first node will automatically be deleted. Now I have to delete the end node. So how I can delete the end node? Will traverse a temporary node till the end, till I found a null, like till I found that temp.next is equals to null. If temp is not null, that I will move forward. If temp is not null, then I will move forward. If temp is not null, then again I will move forward. Now I have came to a specific position where temp, the next of temp is equals to null. That is the end of the linked list. Here the next of temp is equals to null. Now what I will do is I will just simply sorry, not temp.next is not equals to null, temp.next is not equals to null. If I am taking temp.next is equals to null, that I will simply reach to the end of the linked list. And if I am taking temp.next is not equals to null, that I am at the second last element of the linked list. This makes sense and this is clear. Now what I will do is I am at the second last element of the linked list. Now I will what I will do is, previously it was pointing to the last element, the next of second last element is pointing to the last element, and the previous of last element is pointing to the second last element, and the next of last element is pointing to null. Now what I will do is the next of second last element will point to null, and then nothing would be left to point for the last element, so the last element will automatically be deleted. So in this way we can delete any element from the end of the linked list. Now what if I want to delete from the beginning of the link, for any general case, like from the any center of the linked list? So what I can do is, suppose there is a linked list which is A, B and C. These are three values of three nodes in the linked list, three consecutive elements in the linked list, A, B and C. Now what I would do is I will come first reach which element I want to delete. Suppose I want to delete B. Now what I would do is I will do next of A would point to C, and the previous of C would point to A, and in this way B is deleted. Let me explain it one more time, and let me explain it a little bit slowly so that you can understand. Previously what was happening is next of A was pointing to B, and the previous of B was pointing to A, next of B was pointing to C, and previous of C was pointing to A. Now what I would do is next of A would point to C. Now nothing is pointing to B from the previous side, and the next of and the previous of and the next of and the previous of C would point to A. Now nothing is pointing to B from the back side, and nothing is pointing to B from the front side. So in that way B would be deleted. Nothing is pointing to B, so we can't reach B through the either side of the linked list. So in this way the B element, that is the general case of the, that is the central node, that would be deleted. So I hope deleting an element from the linked list is clear. Now let us talk about one more example, that is removing duplicates. How we can remove duplicates from the linked list? Suppose there are two elements like 1 1, 3 3, 8 8, 17 17, 25 25, 25. So how we could do that? In any case, if we are asked to delete the duplicates from the linked list, we have to always remember one thing, that if we have to remove duplicates, then head can never be modified, because head can only be modified when there is only one element, and duplicate simply means minimum two elements or more than two. So in that case head would never be modified. Suppose there are three elements in the linked list and I have to duplicate the remaining three fours, like 4 4 4, and I have to remove these 2 fours, and I only want to keep this 4. So I will traverse until I found 4, and then I will see that okay, if the next of 4 is equals to 4, then I will delete it. If I see that the next of this element is equal to this element, then I will delete it. So this so you may ask that okay, you can take this condition if the linked list is sorted. What if the linked list was unsorted? So in that case I can simply take a set, that is simply take a hash set and insert the values, and if I come to the values which is already present in my hash set, then I will simply delete that value. In that case my duplicates would be deleted. Now let's talk about one is little bit simple question, how we can reverse the linked list. So to reverse the linked list, what we would do is we will traverse the linked list and swap. We will simply swap the next and previous. Swapping next is this, previous is this. So if I swap the next and previous, then my whole linked list will be reversed. Then traverse to the direction of current or previous. Current is the element which I am using to like move one point forward, which is next before swap. And if you reach the end of the linked list, then set head and tail. So in this way my whole linked list will be reversed. Now let's talk about two more problems, and after that I will discuss some like basic level questions, because in doubly linked list doesn't have very much problem, it just needs a little bit of your understanding and a little bit of your time. So let's talk about how we can copy the linked list, and here we have to copy the linked list in reversed order. Suppose I have 1 2 3 4 5, and in the linked list, new linked list which I am copying, I want 5 4 3 2 1. So how I will do that? This is also simple. I will take the first element and then I will insert head. suppose what I am trying to say is, I will first insert 1 in my linked list, then 2, then insert head means insert at beginning, so 2 would be at the beginning, so 2 1, then 3 insert at the beginning, so 3 2 1, 4 insert at the beginning, insert head, 3 2 1, 4 4 3 2 1, now 5 5 4 3 2 1. So in this case I can insert it in the beginning of the linked list and my whole linked list would be reversed. Now what if I have to, like, what if someone asks me how I can copy all the elements in the new linked list, but the order should be same, like I don't want to reverse the order of the linked list. So what I can do in that case? So in that case I can simply add in tail. In this case I will adding in head means adding at the center, inserting the node at the beginning of the linked list. Now I will insert a node at the end of the linked list. So how I will do this? What's the approach? You guessed it right. I will add it at the tail, like I have already said right now. One again, taking the same example, linked list contains elements like 1 2 3 4 5. I will take 1 and insert. Now I will take 2 and add it at the tail of this previous linked list. 1 2 3 4 5, and in this way I have taken all the elements in the same order and my linked list is reversed and my linked list is like printed in the same order, like copied all the elements in the linked list in the same order. Now let's discuss some basic, very small examples of very small problems which we just need to remember. I will not go in deep of this problem because these problems are very similar to the ones which we have already discussed in the similar linked list. You can see those videos if you want to know about those problems, or like I don't think you can get actual value from my videos because I am just recording this video for the sake of recording the videos, and I am trying to give my best, but these are not best. I also know, and you also know. You are just watching these videos to motivate me, and I am just recording my videos to help you to improve my confidence. So let's keep it fair between us because no one else is watching, only me and you. So yeah, so these are some problems. First is search linked list, search in list. So how we can search in list? This is very simple. Like I have already said in single linked list, we will traverse through the linked list, and when we can found the element, and then we will return the element. Suppose the element at the end of the linked list, and in that case we have to search till end, like we have to traverse the whole linked list and then return the element. Now next is free list. Free list means delete all the elements of the linked list, so we will delete all the elements one by one, and in this case all the the linked list would be free. So I hope this was also clear. Now the time complexity of both of these problems are big of n. Now third one is print list. So what is print list? Printing all the elements of the linked list anyway. So how we can print all the elements of the linked list? We would traverse through the linked list and print the linked list. Very simple. So this will also take big of n time, because traversing through whole linked list is taking the number of time which which is equal to the number of nodes in the linked list. So it will again take big of n time. Then find length of the linked list. So how we can find the length of the linked list? We will take a pointer, a count variable, and initialize it with 0. Then we will take a temporary node, and first it will point to the head, and I will traverse it, like I will increment it until it's reached temp.next is not equal to null, and in that way it would point to the end of the node, and I will increment my counter variable each time, like from like temp move one step forward, and I will increment counter one time. Again temp would move one step forward, I will increment counter one more time. Again temp move one step forward, I will increment counter one more time. So in this way, if I follow this approach, then I will have the length of the linked list as the integer. So now this is also, it doesn't matter integer or any that you can decide which data type you want it to be. Now second is find length is already done. Compare the linked list. Compare the linked list is also very basic and also very simple. We have given two linked lists, and we have to check that both these two linked lists are equal or not. So what we will do is traverse through the linked list, both the linked list, and see if the elements of the linked list are equal or not. If the elements of linked list are equal, then we would simply return true, that okay, yes, this is equal. And if any one element of the linked list is not equal, then we would simply return false. That's it. So it will also take big of n time complexity. I hope all these problems and everything that I discussed today about doubly linked list was clear. Doubly linked list was not a difficult topic, and it doesn't have very much hard questions. It has hard questions, but currently I am not discussing very difficult and very big problems from the topic of doubly linked list. So I hope whatever I explained right now and whatever I speak to you is very clear and very concise. I have tried to give my best and tried to be as precise as possible, but I know I can't be like that. I am not that much professional in all this field. I am not that much professional speaking to camera. I have made this file is itself an achievement. I just want to see how much I progressed, and currently I can observe while speaking that I am not mumbling that much like how I was mumbling in my first video. So I definitely feel that my English and my communication skills have improved, and my confidence while talking to camera is improved a little bit. I am not sure that if it has gradually improved or it has, I can see significant changes, but I know I have improved a little bit, like a very a very little bit. And after few more days, after 15 more days, I think I could see a big change. So let's keep it for this now. And one more thing is, like, people say that any habit takes 21 days to build, and I am already doing it for 1 month. So I think it would be a habit, and I could take it further, and I would upload more videos and record more videos for you guys, and try to give more value through my videos, through anything I am learned. I would try to give more and more values to the community and help others. So yeah, that's all for today. Thank you so much everyone. Thank you anyone who is watching this videos. Even a single comment, a single view makes me feel very happy. I know no one is watching, and I don't really want anyone to watch it, because I am just doing it for myself. And even if someone gives me feedback like, you should improve this thing, you should improve that thing, you should improve this thing, that thing, you should speak like that, you should move your hands like that, you should do this to improve the quality of the videos, so I really appreciate that. And if someone is saying that your camera quality is bad, so I can't do much in that, because I only have this phone, and I won't like spend right now in buying a new camera or something like that. If someone says that remove the background or change the background, so I can't do that also, because this is my home, and how can I change the background? Like, how can I change my home? like like that sounds like really very stupid and really very silly. Okay, I would buy a green screen if my YouTube channel gets monetized, and I have a lot of money and I get rich, maybe, probably. That's the future. I don't have to really talk about that thing right now. So yeah, thank you everyone. I talk a lot of shit at the end of the video, so please ignore those things and see until it's necessary for you guys. And this is just a like talking period for me, like talking myself, talking what I feel, talking what, like, okay, ignore all this stuff. I will talk tomorrow. So yeah, thank you so much everyone. Thank you so much. Goodbye, good night, bye bye.